Hello, scholars. It is Miss Bland, and today is Wednesday, August 26th of 2020. We are continuing our lesson on classifying matter. So this is classifying matter part 2. We're going to skip over the do now and go straight to our objectives. We have 3. The first is that Knights will be able to differentiate between elements and compounds. Knights will be able to differentiate between homogeneous and heterogeneous mixtures. And Knights will be able to create models to represent substances and mixtures. So first, let's review substances and mixtures. A substance is any sample of matter that has a uniform composition and uniform properties, meaning that every particle that makes up that matter is exactly the same. A mixture is any sample of matter composed of 2 or more pure substances in which each substance retains or keeps its physical properties. Here are some diagrams of a substance and a mixture. You'll notice in the diagram of the pure substance, every single particle is made up of 1 blue atom and 1 yellow atom bonded together. That's what makes it a substance. In the mixture, you have 2 different types of particles all mixed up. Because they're not bonded, that means they keep their individual properties, and that's what makes it a mixture. So these are 2 categories under which all matter can fall. So all matter is either a substance or a mixture, and we're going to look at the subcategories of each. We're going to start with substances. There are 2 groups of substances. The first group is called elements, and the second group is called compounds. So again, a reminder, substances have a uniform composition and uniform properties. Every particle is exactly the same. So an element is a type of substance, but it cannot be chemically broken down any further. Every atom that makes up an element is the exact same type of element. You'll notice in this diagram that every single atom here is a yellow atom. Let's say that represents oxygen. Because every single atom is oxygen, that makes it an element. Here's another example. Every single atom here is a green atom. We can say that that's carbon. Because every single individual particle is carbon, that means it's an element. All elements can be found on the periodic table. So another example would be pure gold. If gold is pure, that means every single atom that makes it up is a gold atom, and gold is on the periodic table. If you're looking at an example of something that's on the periodic table, it will almost certainly be classified as an element. The second type of substance is a compound. A compound is a substance that's composed of 2 or more separate elements, but they're bonded together. Now, it still has a uniform composition, so even though there are more than one type of element, every particle is still exactly the same. In this example, you'll notice that there are 2 different colors. There are green atoms, let's say those are oxygen, and there are yellow atoms, let's say those are hydrogen. Because there are 2 different types of atoms, and those 2 atoms are bonded together, and every single particle is exactly the same, that's what makes this a compound. In this next example, again, we have multiple particles that are exactly the same. However, each particle is made of 2 different elements. That's what makes it a compound. Another example would be water. Water is a compound because, first of all, every particle that makes up water is the same if it's pure water. And second of all, one single particle of water is made up of more than one element. It's made of hydrogen and it's made of oxygen that are bonded together. So now we're going to get into the 2 different types of mixtures. First, there's what's called homogeneous mixture. Homogeneous. Then there's heterogeneous mixtures. A reminder, mixtures are composed of two or more pure substances mixed together. Now those two substances will keep most of their properties, whether they are physical or chemical properties. So a homogeneous mixture consists of two or more substances that are combined or distributed evenly. Evenly is the key word here. Most of the time in a homogeneous mixture, you can't see the individual parts. That's not always true, but it's true most of the time. And because of that, sometimes we call homogeneous mixtures solutions. A solution is a mixture that has a solute, which is something that is dissolved, and a solvent, which is whatever liquid was used to dissolve it. So salt water is an example of a homogeneous mixture, and it's also an example of a solution. The solvent is the water, and the solute is the salt, because the salt is what dissolves. Here are a couple of diagrams that show what a homogeneous mixture might look like if you zoomed in at the atoms. It might not be this orderly. However, you can see that the red and the blue atoms, or the blue and the green atoms, are pretty evenly spread throughout the box. Here's a diagram that shows salt water. The green and orange are the green and orange atoms are the sodium and the chlorine that bond together to create sodium. And the blue molecules are water molecules. You can see that the green and orange are spread out. Now, this image is a little bit inaccurate because the orange and green should be stuck together. But in general, you can see how it's pretty evenly distributed throughout. The second type of mixture is a heterogeneous mixture, which still consists of two or more substances, but these are combined or distributed unevenly. Here are a couple of diagrams that represent this. On the left side, you have lots of different particles, and they are spread out kind of everywhere unevenly. And in the right side, it's very, very obvious that the combination is uneven. An analogy that we can use to describe a heterogeneous mixture would be cereal like Lucky Charms. If I pour 2 bowls of cereal, is each bowl going to have the same number of marshmallows in it? No, they aren't. And that's one way we can tell that it's a heterogeneous mixture. If it's not evenly mixed, and I pour 2 glasses or 2 bowls of it, then they won't have the same number of that particular element or substance. You can also use Kool-Aid as an example. If I make Kool-Aid, I take water, sugar, and the powder, mix it all together, and pour 2 glasses. They're going to taste about the same because it's a homogeneous mixture.